Now, in addition, the fact that there are not thermonuclear reactions stopping the sun from collapsing inwards under its own gravitational attraction shows that it is not a gaseous object. The sun has to be solid on the inside. The sun's light emission is therefore from its atmosphere and must be as a result of electric discharges or lightning. These discharges must heat the atmosphere to a high temperature, just like we have high temperatures as a result of lightning in the Earth's atmosphere. So in the region at the time of this discharge, the air becomes quite hot. But that heat will quickly dissipate because this only occurs for a moment or two. So these discharges must heat the atmosphere to a high temperature, but the light emission is due to the ionization of the sun's atmosphere, not as a result of a hot surface emitting light. So here we see lightning in the Earth's atmosphere, and this is caused by electrical discharges across the air in the Earth's atmosphere, and light emission results. And this is due to an electrical potential difference between the surface of the Earth and the ionosphere. And the same thing will occur in stars. In fact, all planets and stars have the same electric potential difference, which gives rise to ionization. It gives rise to lightning. Now, gamma rays and particle creation also occurs as a result, and that is in the Earth. But then in the sun, these discharges would be even more intense, and therefore fusion would also occur. So the electrical potential difference giving rise to the lightning in the sun's atmosphere and thus to the sun's light emission is, as I have detailed in the book Planet X, Revealed Gravity and Light, as a result of the nature of the gravitational interaction, which constantly plays against the electrostatic interaction. And everything actually comes from photons and thus from light. Photons split into particles of opposite charge when moving through a region of high enough electric field. Thus, photons give rise to particles, and photons also exist as gravitational energy within particles. And this is illustrated in this image. So if we have a photon moving through a region of high enough electric field, these resonances within the photon, which are particles, and these particles are oppositely charged. And oppositely charged particles move in separate directions in an electric field. The positively charged particle, protons are positively charged, move in the same direction as the electric field direction, which is indicated by this arrow. So the proton will tend to move in that direction. The electron, which is negatively charged, will move in the opposite direction. And this is actually what splits the photon apart and what causes the particles within it to emerge. And then what is left of the energy of the photon? Well, most of the energy goes into creating the mass of the particles. The rest can then exist as photon energy within the particles, and this is shared equally between the particles. But it is the gravitational interaction that causes charges to separate within a celestial object and in atoms, so that the core is positively charged and there is an outer layer which is negatively charged and mainly made out of electrons. In other words, it is the gravitational interaction that gives rise to the electric field or electric potential difference, which then results in light emission. And here I have illustrated the differences between the electrostatic and the gravitational interactions. With the electrostatic interaction, protons and electrons attract each other, whilst with the gravitational they repel each other. So that's the opposite. And the same thing happens with two protons. In the electrostatic interaction, they repel each other, so they tend to move apart. The same with two electrons, whilst in the gravitation we have the opposite. Two protons attract and two electrons attract as well, so they tend to move together towards each other. Then the strength of the interaction in the electrostatic interaction is always the same in all cases, but with the gravitational interaction it depends on the mass of the particles, and because the proton is much more massive than the electron, the strongest interaction is between the two protons. And then comes the interaction between a proton and electron, which is repulsive, and the weakest is the interaction between two electrons, which have very low mass. And in addition, the gravitational interaction strength is associated with the energy within the particles. And so the strength of the interaction changes according to how much photon energy or gravitational energy is within the particles. And I detailed this in articles like Article 181, which is entitled Stellar Cores and Deciphering Gravity. And this actually explains how I came about with the idea of how gravity actually works. And then Article 182, entitled Einstein's Dream Realized Unified Field Theory of Electrogravitation. So these are also in the book which I talked about earlier. Now, so this interaction, the two interactions, the electrostatic and the gravitational interaction, by playing against each other all the time, is what gives rise to the structure that we observe in the universe, from what we see in atoms, which have dense cores, which are positively charged, which is the nucleus of the atom, and then an outer layer, which is made of electrons, which are in orbits around the nucleus, to stars and planets and galactic nuclei and even quasars, which all have positive cores and negative outer layers. Now, atmospheric electrical discharges occur in all celestial objects, including planets. It occurs on Earth as well, but to a minimal extent compared to what occurs in the atmosphere of a star, like the Sun. In addition, it seems that all celestial objects generate gravitational energy, or photons, in their core as a result of decay of unstable nuclei or fission. And this is detailed in Article 192, entitled Neutron Stars and Fission as a Star's Internal Energy Source. It thus seems that stars are not very different from planets. The main difference seems to be size, which allows stars to have more lightning in their atmosphere and thus emit more light and have matter creation as a result, which then gives rise to a solar wind. This suggests that stars and planets are formed through the same process, and that seems to be a similar process which gives rise to CMEs, or coronal mass ejections, but at a much larger scale from galactic nuclei. And for more details, you may look at Article 215, Dark Matter, Galactic Evolution and Star Formation. And this is illustrated here, that galactic nuclei have episodic matter creation events, which are like what occurs in stars, and we call CMEs. And this means that a large amount of energy in the form of high energy photons, or gamma rays, are emitted. And these are emitted within the region which is the outer layer of the galactic nucleus. There's a high electric field there, so they split into particles. The particles then condense into dense, there's fusion as well. All nuclei that we are part of the periodic table are formed. These then form cores of objects. Planets and stars then are formed. They are ejected and they go into elliptical orbits. And then stars die at around the aphelion position, that is, they stop emitting light and they go back towards the galactic nucleus and are still massive objects, but are not emitting light, are not seen. And this is why galaxies seem to have these arms, these spiral arms, that do not seem to be complete. They do not come back to the galactic nucleus, because the stars in that region are not emitting light. So in conclusion, because the sun goes dark or turns off as observed during the so-called SDO eclipse season, the sun and therefore all stars cannot be powered by thermonuclear reactions from the core, nor can the sun's surface be any hotter than 750 Kelvin. The sun has to be electrical in nature and emit light as a result of electrical discharges in its outer layers or atmosphere. Stars and planets are only different in terms of size and thus in the amount of gravitational energy they are able to generate in their cores. The cores are solid and dense in both cases. The larger objects generate more gravitational energy, which gives rise to a stronger electric potential difference in the outer layer and thus more intense lightning and light emission. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.